In this video, I'll show you the fastest ways I know to solve these 9 questions. I'm Risav Roy, I'm an SAT math tutor, and most of my students have scored in the top 10% on the SAT math, and some have even scored in the top 1%. Grab your pencil or Apple Pencil, and let's begin. In the XY plane, there are 3 points, A, B, and C. Point A is the coordinates of 1, 0. Point B is the coordinates of 0, 0, and point C is the coordinates of -1, 0. Which of the following gives the possible angle measure in radians of angle A, B, and C? The fastest way to solve this is to recognize that anytime the SAT gives you these 3 lines, or really these 4 lines up until right here, all this is saying is that it's drawing a unit circle for you. So this is just a unit circle question. Now, anytime you get a unit circle question on the SAT, all they want you to look at is point C, because point C forms the angle. The trick to this is that point C on the unit circle, like this third point that forms the angle, is always cosine theta sine theta. Any point on the unit circle is represented as cosine theta, sine theta, where theta is the angle measure. So what we can do, anytime you see a unit circle question on the SAT, because they're always like this, the SAT always draws it out. It never says unit circle. Is you go to Desmos, you plug in cosine A, comma, sine A, and then let's plug in each of the 4 answer choices for A. And watch, this is going to blow your mind. 588 pi over 6. What we want to do, what we're basically doing right now, is we want to make cosine A sine A equal to C. That's it. Cosine theta sine theta, which is cosine A sine A, has to equal this C point at -1, 0. That's all we're looking for. So I don't know why my Desmos is bugging out right now. But it shows right here it's something crazy, but on the graph, as you can see, it's just 1, 0. And 1, 0 is not -1, 0. So this does not work. Now, instead of 588 pi over 6, let's put in 591 pi over 6. See how this is 0, 1? That's still not -1, 0. How about 594? See how that's -1, 0? See how that matches C? The reason why this works is because any point on the unit circle can be graphed if you know its angle measure. And the beautiful thing about this question is that the SAT has to give us the angle measures. So we can just substitute it into this formula that you can memorize, cosine theta, comma, sine theta, which is basically the X and Y point. And then you can solve for this value directly. Okay, perfect. So C right now seems to be our answer, but we have to check all 4 points. 6, 12. Okay, and this is at 1, 0. I don't know why this is labeled weird, but as you can see, it's 1, 0. I'm just gonna stop messing with this because my Apple Pencil is not cooperating right now. Okay, let's move on to the next one. The function f is defined by f of x equals a to the power x plus b, where a and b are constants. In the xy plane, the graph of y equals f of x has an x-intercept at 2, 0, and a y-intercept at 0, -63. What is the value of a plus b? Okay, there is, complicated math way to do this, but again, I'm going to show you the fastest ways. I'm going to show you the easiest ways. Here's the easiest way. You just use Desmos because Desmos will give you this equation for you. If there are a ton of constants, you can do something called regression, which is basically finding the function between the points. And it's really simple. I know regression sounds complicated. It's way more simple than you think. So we first have to create a table, enter the points, and we know that we have to use regression when we're given at least 2 points and we're trying to find a function between 2 points. That's it. Whether it's a line between 2 points, a parabola, an exponential, as it is in this case, we can do that. Now, if you click the button that I just clicked, this one, add regression, and then you go to exponential regression, the problem is that this form, the y equals a times b to the power x, is not the same form as this. We need a to the power x plus b, not times. Oh, I guess. Yeah, I guess it's a completely different form then. So what we need to do is we need to create a custom regression. I know this may sound complicated, but I promise you it's a lot simpler than you think. So let me erase all of this and then let's go back to Desmos. First, the first step to creating a custom regression is enter exactly what it says. Uh, y equals ax plus b. Before we can get the answer, there are 3 things we need to do. The first thing we need to do is delete the equal sign and change it into a tilde because that's telling Desmos do regression. The second thing we need to do is change the x to an x1 because we need to tell Desmos look at the table, look at the x values in the table. And how we do that is we type a 1 directly after the x. It automatically subscripts to x1 like that. I just typed a 1. I didn't do anything else. Then go to the y and do the exact same thing. See how it solves for a and b for you. Like I don't even know why this is allowed on the SAT. It, you don't have to do any math, and it solves the question for you. You have to find the value of a plus b. You don't even need to type in 8 plus negative 64. You just type in a plus b. 8 plus b, negative 56. Why is this allowed on the SAT? I have no idea. But until it's not allowed, use it. See, look at how much work we had to do. Nothing. No math. Just negative 56. Beautiful. Okay. Oh, by the way, there's a delete all button on the left. Let me show you that one more time. You didn't catch that. Settings. So you had to click this one and then delete all. I didn't know that until like a few days ago. Okay. This question, I saw this on my SAT. And I take my SAT basically every SAT, I take it with my students because I can. Tutors, anyone is allowed to take the SAT, not just tutors or students. But I saw this on my SAT and I came out of the testing room and a student called me up and she was like, Roy, we went over this question in class, right? I'm like, yeah. And she was like, I saw this on my SAT. Like, we both saw this question on the SAT and we practiced it before the SAT because it was on a past SAT. So the SAT has put this very unique question twice. If I was a student, I would memorize it because the student that called me up, we worked on this question before she took the test. Let's draw it out and then I'll show you like the way to like memorize how to solve it. Basically, anytime you get a geometry question, just draw it out as fast as you can. because typically you don't want to waste a ton of time on the drawings. Now, A, B, C. Anytime you have an isosceles triangle, the SAT always tests this, that it wants you to know that the angles that are opposite to the congruent sides are also congruent. So label these angles, B and C, as congruent. Now point G divides BC. And then point H lies on AB. You want to make it look like, this isn't an equilateral triangle and this isn't the midpoint, right? Just make it all scattered so you don't confuse yourself. Is it the midpoint? It never says it is. And then this one is J. And what you can do is connect these. Let's draw some better lines. And from here, you'll know that these two angles are congruent. Um, this one and this one. Whoa. Let's put these, actually for now, let's remove the isosceles marking. So, because we don't need it for this question. I know because I wrote these questions based off of real SAT questions. Okay. BHG is congruent to GJC. From here, all we need to do is we need to notice that these two triangles, this one right here and this one right here, are congruent. Because, did I say congruent? I meant similar. These two triangles are similar because of angle. And similar triangles are proportional in their side lengths, which is important. Because when we label the rest of this diagram, we realize that BG, so this length right here, from here to here, BG is 7/9 of the entire length. So if the entire length is X, then this would be 7/9 X, and GC on this other triangle would be 2/9 X, because 7/9 plus 2/9 is 1. So the entire thing forms 1x. Hopefully that makes sense. Why this is 2/9. That's important because we need to set up a proportion. From here, CJ is 4, and we're basically looking for BH. So this. All we need to do is set up a proportion, meaning we set up two ratios. Now, what I like to do is I like to set up ratios between like the same angle. So for example, this third angle to the third angle. See how we mark the angle as like with 3 markings? So the side that's opposite to the third angle divided by the side that's opposite to the third angle on the other triangle. So x divided by 4. That's our first ratio. And we set this equal to the side that's opposite to the second angle, which is 7/9 x. I guess we already used x down here, right? So let's change this to y, just so we don't confuse ourselves. And then since we use the side opposite to the second angle, we use the side opposite to the second angle on the second triangle. We set up two ratios just like this. And we cross out these because the x's cancel out. From here, we can just put this into Desmos. We don't even need to solve by hand. So y divided by 4 equals 7/9 divided by 2/9. And what we'll see is that y is equal to 14. This is our answer. Y is equal to 14. This isn't exactly the question that was on the SAT that me and my students saw, but this is very similar. I'll leave it at that. Y equals 14. If I was studying for the SAT, if I was still in high school, I would memorize this question just in case because it was the hardest question on the June SAT. Well, not this exact one. Okay, next one. Two numbers, a and b, are each greater than 0, and the fourth root of a is equal to the seventh root of b. For what value of x is a to the power 8x minus 5 equal to b? So a lot of you guys probably got this equation. So the fourth root of a is equal to seventh root of b. Now the second equation is a little bit harder, but that's okay. So a to the power 8x minus 5 is equal to b. This is the second equation. This part, like for what value of x, is kind of there just to throw you off. So if you ever see this question or like something very similar, because the SAT does repeat these questions just with different numbers, then just focus on this last part. Don't focus on for what value of x. Like it's basically saying we're solving for x. That's all. These are your two equations. What we want to do is since B is isolated on the second one, we want to isolate for B on the top one. And I'll show you why in a second. But let me first do that. Okay. So to isolate for B, we just take this to the seventh power, right? And then this turns into um, the fourth root of A to the seventh power is equal to B. Now B is isolated, and this can actually turn into A to the 7/4 if you know your exponent rules well. If you don't, just think of the power as the numerator and this root part as the denominator, always. Okay. From here, I think a lot of you guys will see what to do next. You just set them equal to each other, right? Because B's. So A to the power 8x minus 5 equals A to the power 7/4. And then from here, we can actually set the 8x minus 5 equal to the 7/4 because the a's, they're both exponents of the same base. We're allowed to do this. And something else that we're allowed to do is put in this equation into Desmos. We don't even need to do any more math. And since we get a decimal, just change this to a variable other than x or y. I always pick a for some reason. And then on another line, just type in that variable one more time and then press this fraction button, like right here. Press that. X equals 27 over 32. Beautiful. That's it. Next one. A model initially estimates that there are 28,700 bacteria on a petri dish. 12 days later, the model estimates that there are 114,800 bacteria on the petri dish. Assuming exponential growth, the formula B equals A times 2 to the power XD gives the estimated number of bacteria on a petri dish where A and X are constants and B is the number of bacteria on the petri dish D days after the initial measurement. What is the value of X? Super long problem for absolutely no reason. This problem does not have to be this long because all the information we really need is this thing and this thing and this thing. Everything else is irrelevant. Let's set up an XY table, except X is not X here. X is actually D. In this formula, X is actually, it's kind of deceptive. And I don't know, I mean, I get it why the SAT does this to deceive students because they don't want everybody scoring high. It's a test after all, right? If everyone scored high on a college entrance exam, it wouldn't be meaningful. So x is actually d in this case. And the x term in this formula or in this function is a constant. So in this formula, x is a constant. It is not a variable, meaning x is a set number. That's why all the answer choices are set numbers. So if we plug in what we have, it initially estimates that there are 28,700. So at day zero, because that's the initial estimate, that's the starting point, you had this much bacteria in the petri dish. 12 days later, it was 114,800. And if we divide 114,800 by 28,700, we actually get 4. So in the 12 days, it increased 4 times. Now, you might be tempted to be like, okay, so let's do 4 divided by 12, but that's not how exponential functions work. We know that it is an exponential function because it's 2 to the power of d, right? So it's doubling. Now, how many times did this function double over the 12 days? It doubled twice because if you double something twice, it increases a total of 4 times because 2 times 2 is 4, right? So over the 12 days, it doubled twice. That means it doubled every 6 days. And that's why our answer is 1/6 because we're looking for the value of x. X is a constant. Now, if our equation, let me put our equation right here. B equals A times 2. B equals A times 2 to the power xd. If x is 1/6, that means that if we simplify this, this is just d over 6. So every 6 days, this doubles, right? If you put in 6, this is your first double. This turns into 1. If you put in 12, it's going to be 12 divided by 6. This is your second double. So it doubles every 6 days. That's why x has to be 1/6. Okay, hold on. I gotta. All right. So just like the question, I think 2 questions ago, this question was also on the most recent SAT, just slightly different because we can't put the exact questions, but a slight difference. It's not much of a difference. So let's take a look. The rate of an object is increasing by 1,538 meters per hour per second. Which of the following is the closest to this rate in feet per second? Use 1 meter equals 3.28 feet. Whenever you see these parentheses and some unit conversion, you always know it's a unit conversion question. So immediately start thinking that way. We need to convert units. The first trick for this question, or at least the first curveball that SAT throws at you, is increasing by. It does not matter. It's not relevant because all we're looking for is to convert the rate, and the rate of the object is 1538. It does not matter that it's increasing at all. We just want to convert 1538 into feet per second. The second curveball is this per second or per hour per second. Most students have never seen this before, and like that's normal. So here's how we do it. Again, this was on the most recent SAT, or a very similar version of this question. Okay. 1538 meters per hour per second. That's how we write it. Anytime you see per, it's division. Now, what do we do with this? This is pretty crazy. So what we want to do, we have to put parentheses around the first division. It's always the first one because that's how order of operations works. Meters per hour per second looks like this. because the per second was divided to the meters per hour. That came first. So that has to have the parentheses. Now, anytime you divide by something, you're also just multiplying by its reciprocal. So instead of dividing by seconds, you're really just multiplying by 1 over seconds. So this just turns into meters per hour times seconds, just like that. So we want to convert this into feet per second per second. Now, if you're taking chemistry in your high school and you learn dimensional analysis, then basically you want to use that exact method to convert these units into this one. But if you haven't learned that, then I'm going to turn into a chemistry teacher right now. No, I'm not. But I'm going to teach you how to do this. So let's actually make this a little smaller. But the first thing that we want to start converting is we want to go from meters to feet because that's going to be the easiest conversion. Then we'll go deal with all this stuff. So to convert from meters to feet, basically we want to multiply by, I feel like I'm moving okay. We want to multiply by 3.28 feet over 1 meter. Why did we do that? This fraction is basically 1 over 1. So we're not changing this number at all. We're only changing the units because we're multiplying by basically 1. If you see a meters in the numerator and in the denominator, they cancel out. And this new unit on the numerator gets replaced with feet. Okay, 1538 times 3.28 feet over hour times second. That's it. So this is our new fraction when you just convert it into feet. These two numbers get multiplied because we multiplied this fraction. Okay. From here, the next step is to convert this hours into seconds because we want feet per second per second. So again, we just want to write this down somewhere that we want feet per second, which is just feet per second squared. Or you could think of it as feet per second times second. So we just need to convert this hour into seconds. How we do that is we multiply 1 hour over 60 minutes and then 60 minutes over, wait, no, not 60 minutes, 1 minute over 60 seconds. And what this will do is it will cross out the minutes, it will cross out the hours, and you're only left with this last seconds here. And what you'll see is that there are two 60s. So really all we're doing times 3.28 over 60 squared. And these units, all the units that are left are just these three. Feet per second times second. It's exactly what we want, right? I'm circling a lot. It's getting messy. Okay, 1538 times 3.28 divided by 60 squared. Okay, and this is approximately 1.4. And it says what is the closest to this rate, so we don't need an exact answer. And it is 1.4. Okay. Hopefully that question was a little more clear for you right now, because that one was the hardest question on the last test. It's just that some versions didn't like Some versions of the SAT don't get the same hardest questions. Like the test that I took with my students, I didn't see that at all. A circle is inscribed in a square such that the circumference of the circle touches the midpoint of each side of the square. The length of the diagonal of the square is 300 units. What is the area in square units of the circle? Okay, here's what you want to do. Do you notice how I started drawing this circle right as I noticed it was a geometry question? Whenever you see circle, whenever you see square, whenever you see like midpoint, this is a geometry question. Just start drawing it. That should be your first instinct for these geometry questions. You need to draw it in order to see it. Otherwise, you're just going to be sitting there wasting precious time on the SAT, wondering what to do. I don't want you to do that. Okay, we're going to draw a diagonal, right? And this is 300. Let's draw a better 300. What is the area in square units of the circle? You always want to work backwards from what you are trying to solve. Constantly ask yourself, why can't I solve this question right now? What information do I lack? Area of a circle, let's say circle, the area of a circle is always pi r squared. So all we need to know is just the radius. Now, if we start drawing radii, we see that, you know, they have nothing to do with the diagonal, except for when we draw a diameter. If we draw a diameter, we see that this diameter length is exactly the same length as one of the sides of the square, right? And the diameter is just twice the radius. So let's draw this. Let's label this 2r. Let's also label this 2r. And this 2r, because it's a square. Okay, what you'll notice is that if if squares have right angles, what you'll notice is that this triangle right here, it's just a 45, 45, 90 triangle. If you know your special triangles, that's awesome. I'm glad you have them memorized, but if you don't, shame on you. So if this is one side of the square, then the hypotenuse will be s root 2. That's it, right? Because that's the special triangles. So that means that s root 2 is equal to 300 because 300 is the diagonal, it's the length. So that means one of the sides of the square is just 300 divided by the square root of 2. I don't want you to solve for this yet. Let's do all the work first, and then we'll do all the math all at once in Desmos after. We found the side, and we also know that this side is equal to 2 times the radius, because the side is equal to the diameter, and the diameter is equal to 2 times the radius. So this is equal to 2 times the radius. Now, if we divide both sides by 2, we're going to get the radius is equal to that. And what we can do, we can actually first cross these out. This is just 150 over the square root of 2. And since we're looking for the area, we can plug this radius in. Radius equals 150 divided by the square root of 2 into this formula right here. So it's just, whenever you see pi, don't put pi into Desmos because all of the answer choices are typically in pi, right? So you just want to read the numbers of the answer choices, forget about the pi. So just radius squared. 150 divided by the square root of 2 squared. And that's 11250 pi. All right, we added the pi back in. Okay, perfect. Let's move on. A circle has diameter CD and EF. The circumference of the circle is 136 and the length of arc CF is 3 times the length of arc DF. What is the length of arc DE? I'm gonna say that this is probably the easiest question out of these nine, but I've seen so many students just completely stumped here. So if you're completely stumped, I I've seen it happen. Like I get it, but at the same time I don't get it. Because when you see the solution, you won't get it either. You're like, how did I not see this? C, D, E, F. And then the circumference is just going to be 136, right? I don't want to label it as C because we already have a C. The SCT, I guess the SCT does that to, you know, trick you. Okay, CF, this length is three times the length of arc DF. So it's three times its neighbor, meaning this is 3x, this is x. Pretty simple, right? Just proportions. This is three times bigger. Now here's the crazy part. If this is 3x, then this is also 3x. And if this is x, this is also x. Do you see the solution yet? Okay. From here, the circumference, what is the circumference of a circle? It's just everything added up, right? 3x plus x plus 3x plus x is equal to this 136, right? So then 136 equals 8x. X equals, what is 136 divided by 8? 17. Okay, perfect. We just need to find the arc DE. Make sure you don't put 17 as your answer. We just need to check what the question's asking. So the question is asking for DE, which is 3x. So we basically need to multiply this by 3. Our answer is 51. Wonderful. Yeah. Hopefully, if you got stumped on that, now you know. Okay. Most students have seen a question like this on the SAT, where it gives you these four crazy points with constants all over it on the X's and Y's. There's a really fast way to solve this, I promise. For each real number R, which of the following points lies on the graph of each equation in the XY plane for the given system? 12x plus 6y equals 18, 30x plus 15y equals 45. A is that, that is B, that is C, and then D looks really crazy. Here is the fastest way to do this. You just plug in 0 for R. I know typically tutors will say, don't plug in 0, don't plug in 1. For this question, it's totally fine. I totally get that for some very small cases, like don't plug in 0, don't plug in 1. But this question is fine. Only plug in 0 for now. Here's how to identify this question, first of all, because you want to be able to identify this question to be able to use the solution that I'm about to show you. If you see these 4 points and they have crazy constants in the X's and Y's, then check these two lines. There will always be two lines up here. If they're the same line, then it's this question. It's the question that we're talking about right now. So let's check if it's the same line, because they're always the same line for some reason. The SAT loves giving this question. 15y equals 45. See how when I unhighlight and highlight the red line, it's the same line. Zoom in even more. Same one. Also, you can always click this home button. Do you see that? You can always click that to go to your default viewport. Okay. When we plug in 0 for R, for all four of these, here's what we get. We get 0, comma, 9 tenths. Because anything with an R just disappears. It just turns into 0. That's the fastest way to do this. So plug in 0 for the next point. What do you get? 0, 5/6. Next point, 3 halves, 0. See how fast this is? 12, 20. And here's the thing. These 4 points have the correct answer will have the point on this line because they're the same line. We can actually delete the second one. just to keep it simple. So if we plot these 4 points, let's say 0, comma 9/10, see how this is not on the line, right? So it's not an answer. Then the next one is 0, comma 5/6. 5/6. See how this is also not on the line? Not an answer. Next one, 3/2, comma 0. Oh, okay, comma 0. This is on the line. Perfect. Now, here's the thing. When you plug in 0, there can be 2 points that are on the line. So you just have to check all four answer choices. But a lot of the times, there's only one that is on the line. And if there are 2 points, you just plug in another value for R. I'll explain that just in a second. Just let me finish this solution. So 1220, there we go. That's all the way over there. That's not even close. Okay. The reason why this works is because when you plug in a value for R, like this point, the correct answer, which is C, should fall on these two lines, which are the same line. It should fall on these two lines for any value of R. So if we pick a really simple value of R, like R equals 0, this has to work, right? Like C has to work, or one of the answer choices has to work. Now, if you get two answers, like let's say D also worked for some reason when you plugged in 0, then you just plug in 1. And I promise you, at that point, there's only one that's going to work. So that's the fastest way to do it. In my opinion, is a pretty fast way. Parents, if your child is signed up for an SAT and is taking the SAT in the next 3 to 6 weeks, I want to work with you. I'm an SAT math tutor, but I only work with students that are signed up for an SAT soon. The reason why is because I've noticed that students are a lot more motivated when they actually have a test that they're signed up for. So right now, I just don't work with students that aren't signed up for an SAT. But if your child is signed up for an SAT, then go to thesatmath.com and sign up for a private one-on-one tutoring session with me. On that tutoring call, I will tutor your child for 90 minutes, and then the next 30 minutes is just going to be me talking to you about the programs that I have for your child. That's pretty much it for this video. For all the students out there, awesome work. I'm rooting for you.